In this video, we are going to convert y equals e to the x into a polynomial. So basically, we're just going to rewrite this equation as if it were a polynomial. And of course, the way we would do that is we would use a Taylor series. And to keep things simple, I'm just going to center that Taylor series around x equals 0. So first, I'm just going to label f of x as equal to e to the x. And so now what I'm going to do is I'm just going to write the Taylor series for f of x centered about x equals 0. So what that would look like is it would be f of x is approximately equal to f of 0 plus f prime of 0 times x plus f prime prime of 0 over 2 factorial x squared plus f prime 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 of 0 all over 3 factorial x cubed, and if we were to keep going, our general value would just simply be the nth derivative of f at 0 divided by n factorial times x to the n. So this is basically what we have. And remember, the reason why it's an approximation is because we're not using an infinite number of derivatives. We're only using up to n derivatives. Now there's something really special about this. It's the fact that we're using e to the x. And when we keep taking the derivative of e to the x, we keep getting e to the x, because the derivative of e to the x is just itself. And as a result, f of x is going to equal f prime of x. It's going to equal, which equals f prime prime of x, which equals f prime 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 of x, which equals the nth derivative of x. So all derivatives of e to the x is equal to e to the x, which is equal to f of x. So all of these values have to be equal to each other. And so this is f of x, this is also f prime of x, this is f prime prime of x. It's all derivatives of f of x, right? It's the same exact thing as f of x. And when we evaluate that at x equals 0, we just get 1. So as a result, all of these have to just simply equal 1. So now that we know this, we're basically just rewriting this as f of x is equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus, we keep going until we reach some n value, x to the n over n factorial. So we can see that this is what we get if we know f of x equals e to the x. And of course, we are just going to write this in summation notation, which would just simply be f of x is equal to the sum from k equals 0 to n. So I'm going to use k in terms of these values right here that are increasing by integer values until we reach n, right? Until we reach n. And so that means we would say this is just x to the k all over k factorial. So this is basically how we can write e to the x as a polynomial. It would just basically look like this. However, of course, I forgot to write. This is an approximation, because we're not using an infinite number of derivatives. So we're only going to get an approximation of what e to the x looks like. All right, we have to let n approach infinity. And so in that case, f of x, which is also equal to e to the x, is just simply going to equal the sum from k equals 0 to infinity, because we're letting n approach infinity, of x to the k over k factorial. And so this is how you write e to the x as a polynomial.